Okay, so just to finish here, so this is how we calculate the percentage error. In this lab, the theoretical is going to be 9.81 meters per second squared. And you're going to do it 3 times. Once for the tennis ball, once for the birdie, once for the cork. And you're going to place in here what you got for each one of those. So the first time the tennis ball, second time cork, and third time birdie, or whatever order. Now, these straight lines are called absolute value. And what that means is, let's suppose you're doing it for the birdie. So you put 9.81 meters per second squared in here, and maybe you got something like 18 or 16 meters per second squared for the birdie. Okay, and so when you do this, you might think you're going to get a negative on the top. But that's what these straight lines mean. Absolute value means ignore the negative if you get one. Just drop it and do the percentage. Okay, so again, you can handwrite this out on the same sheet where you were solving for your A's. So you can do your A's first and your percentage errors. And don't be shocked if you get things like 16, 18, or 6 meters per second squared for your accelerations. It's because of sources of error. And it always happens in this lab. And it's really a good lab to start off with to see how many sources of error there are. So the table and the that was the questions. The table and the questions all go into the section that's results. The data table, the chart, the graphs. So you filled out this table on your lab sheet, but when you're typing up the lab, you actually have to insert a table. And on Word, it's quite easy. Go to Insert on the opening screen, choose Table, and then choose Customize. And you can tell it how many different columns you want, how many different rows. It's not a bad piece of knowledge to have for the rest of life. So if you don't know how to create a table, play with it. And when we're back face to face, I can show you. Okay? So fill out the table, all the answers to your questions, they go in the results section of your lab. The next section is discussion, and it says discuss the possible sources of error, and you must have at least 5. So lots of people put 6 and 7 in just in case they screw up a couple of them. You have to explain them, and you have to suggest an improvement. And I would suggest start with the big guys. Okay, don't bury the lead. Start with the ones that are most obviously sources of error. So pause for a second and think about what were some sources of error. I would hope one of them that you would think of would be the timing, right? The timing of the stopwatch. Nobody's reaction times are perfect. So you have to start it exactly on go and stop it exactly when it hits the ground. And all of us, no matter how much caffeine or how little caffeine we've had in the day, we're not going to have perfect reaction times. So that's a huge one. Another huge one would be you and your partner in sync, right? You and your partner has to drop at the same time you start. It's a little bit different from your reaction time. Probably one of you counted 1, 2, 3, go, but was the other one in sync with you? So maybe an improvement there would be both of you should have counted 1, 2, 3, go, so that on go, one of you drops the item and the other starts the stopwatch. So getting you and your partner in sync is the second source of error. What could you have done for the reaction time one, the first source of error to improve it? Really what you did, drop it over and over again. But 4 times isn't enough. You should drop it 8 or 20 or 2,000. Okay, so those are 2 sources. What are some other sources? Certainly one is air resistance, right? And there's nothing we can do about that, except maybe pump all the air out of the cafeteria before we did the lab. Doesn't seem to be reasonable. So air resistance, and obviously it's going to affect some of your objects more than others. The little birdie would be affected by air resistance a lot more than the tennis ball. And that's why you would expect your birdie maybe to be bigger, have a bigger A than your tennis ball, because it gets slowed down so it takes longer to fall. Another source of error was probably, unfortunately, you measuring the height of the drop zone. Was your partner holding it on the ground? Was the measuring tape exactly straight and perpendicular with the floor? Did you measure right up to the exact height where you dropped the objects? All those things go into measuring the height of the dropping area. How would you improve it? Do it more than once, be more careful, get someone to check it, etc. Another one would be, where was your partner that was timing? Where was the partner who was timing the items? Where were they located? Were they standing up and looking at the ground to see when the items hit the ground? Where should they have been? Probably lying on their tummy, on the floor, eye level to when it hit the ground, so that their perception of when it hit the ground was accurate, as opposed to standing above it, a couple of feet away, really guessing when it hit the ground. So that would be another one. Another one, the partner dropping. Did you drop it the same way each time? Were your fingers on the sides or on the top, or did they change? Was the orientation of the object the same, with the exception of the tennis ball, which it wouldn't really matter, but for the cork or the birdie, it would matter which way you dropped it. Another one, I don't even know what number we're on, would be, where was the partner's arm when it was dropping? Were they holding it straight out? Because sometimes straight isn't always straight, and so it might not be exactly the same height all the time. It's why I suggested lying it on the rail, so you would always know, like lie it on the rail and be horizontal, so that you would always know it was exactly the same height. Okay, so I'm sure there's more, but those are just a few. The last part of the lab is the conclusion. So this is where you talk about your results. So tell me, for the cork I got this, 8.62 for acceleration. And for the tennis ball I got 5.73. And for the cork, or for the birdie I got 14 meters per second squared. Tell me what you got. And then talk about, do they make sense, shape, size, and mass wise? Does it make sense that the heavier one has a bigger acceleration, or the one with the feathers has a bigger acceleration? Like, talk about it, and talk about, did you predict correctly? What did you learn about the size, the shape, and the mass based on this experiment? And then what sources of error were maybe the biggest, played the biggest role? So your conclusion shouldn't just be a sentence or two, and it must include your final results. You must include what you got for each of the accelerations, okay? Unless you're working for the CIA and it's top secret results, we don't bury those final results in the lab. We mention them in the conclusion. So if you're really bored over these days, you could start to type up your lab. If we were in class, this is the next sheet I would give you. And if we were in class, or if I was allowed to post on the group, I would post this sheet on the group, and I would ask you to do the first 5. The next set of videos that I will do will be the first 5. The first 4 should be pretty straightforward. Number 5's a lot like the one dropping. Oh, number 5's a little more complicated. I was going to say like dropping the balloon, but I think that's like number 2. But number 5 will be the teacher falling and the sound going back up. So I'm just holding it here in case you want to be able to see it well, in case you want to try these. Okay? So feel free to give them a try. They're maybe a little trickier, but we're moving along here, and we're getting close to the end of these. And please do try them. I can make them look easy by solving them, but you need to try them to get a hang on how to set them up. Okay? Don't let number 3 fool you. It's easier than it looks. Okay? I think it's only a one-stepper. Alright, so give these ones a try. And then the next time we gather, I will do the solutions to these. Okay? Take care, and hopefully see you soon.